Alright, for our next lesson, we're going to be talking about Section 1.7, Deductive Reasoning. The objective for this section is to recognize that geometry is based on deductive reasoning, identify undefined terms, postulates, and definitions, and understand the characteristics of theorems. Whew, it's going to be a lot, let me tell you. What we're going to be working on in class is going to be on page 42 to 43, 1 to 7 odds, 8 to 12 all, and number 14. So kind of brush up on those. Give it a look before we get started. Alright, so let's get started by talking about deductive structures. Deductive structures. A system of thought in which conclusions are justified by means of previously assumed or proved statements. Wow, that's a mouthful. So what do you think we're actually talking about here? A system in thought, so a way that we're thinking, in which conclusions, so the ending, are justified by previously assumed or proven statements. Give it some thought. Let's see what else we got here. Here's what it contains. Undefined terms, assumptions and postulates, definitions, theorems and other conclusions. Looks like we got a lot to learn tonight. Alright, now let's talk about undefined terms. Undefined terms are terms that are described but not defined. We'll see in honors geometry, a lot of terms that we end up encountering are going to be undefined terms. We really can't put the restrictions for definitions on them, but we can talk about them and discuss them. Examples would be points, lines, and rays. Those were things that we actually described. They don't really have a true definition. Next, we're going to talk about what a postulate is. A postulate is an unproved assumption. Theorems are always proved. They're always facts. Postulates, they can't be proved to work in all cases, but they can't be disproved either. Now, definitions. How ironic, the definition of a definition. Definitions are the meaning of a term or an idea, which I think we kind of already knew. It sounds kind of similar to what we had before, a description, but definitions, as we'll see as we move on, they're going to have other restrictions that are going to be associated with them. Alright, now we get into the meat and potatoes of our lesson, conditional statements. A conditional statement, statements that are written in an if-then form. If it rains, then I will need my umbrella, or else I'll get wet. The if part is called the hypothesis. It's the this might happen. The then part is what would happen afterwards, the conclusion. The statement if P, then Q can get written as P, the equal sign arrow, Q, and reads P implies Q. So this would be the long way of writing a conditional statement, if P then Q. This would be the symbolic way of writing it, and this would be the way the symbolic way is read. Alright, now we're getting to the converse. The converse. It's a conditional statement in which the hypothesis and conclusion are switched. So from our previous slide, we had P implies Q. For the converse, you flip-flop them. Q implies P. So if we had that statement, that original if-then statement that I gave you, if it's raining, then I will need my umbrella, and we flip that around for the converse, if I need my umbrella, then it's raining. The if stays put, the then stays put, but you flip-flop the meat and potatoes. Alright, back to those good old definitions. Definitions, they're reversible, which means they can be written as a conditional and a converse, and in both cases they'll be true statements. Theorems and postulates are not always reversible. So when we have a theorem, if we flip-flop the if and then part, the meat and potatoes part, it doesn't mean that it's going to be true. Alright, so now let's start talking about some conditional statements in which the conditional and its converse are going to be true. Let's go back to my original statement. If it's raining, then I will need my umbrella. Let's flip that around. If I need my umbrella, then it's raining. Is that always true? Can you think of a case where I might need my umbrella and it's not just raining? I can definitely think of one. When it's snowing or when it's sleeting, I would still want my umbrella or else I'd get wet. So, let's think about some stuff. What do we know for sure that's going to be reversible? Definitions. Definitions are always going to be reversible. That's one of its conditions. So let's think about some definitions that we definitely know. One of which that pops into my mind is going to be the definition of a right angle. So let's see. What is the definition of a right angle? Well, a right angle is an angle that measures 90 degrees. Well, that's good. Let's try and write that as a conditional statement, an if-then statement. Well, here's what I'd have. If an angle is a right angle and its measure is 90 degrees. Well, that's always true. If it's a right angle, its measure is 90 degrees. Now let's flip it around and let's see what happens. Make sure it's always true. If an angle measures 90 degrees, then it's a right angle. Is that true? If it measures 90 degrees, then it's definitely a right angle? Yeah, absolutely. Alright, let's get to some good stuff. We got some real meat and potatoes going on right here. So some examples. Here we go. Write the converse. If today is warm, then I will wear shorts. What would you have for your converse? If today is warm, then I will wear shorts. Let's flip-flop it, and don't forget, leave the word if, leave the word then, and flip-flop the meat and potatoes of the sentence. Alright, here's what I got. If I'm wearing shorts, then today is warm. So we flip-flop it. Is that true? Not necessarily. I know for you guys, when you're in PE, you're going to be wearing the shorts in the winter. So let's move on. Let's try another example. Comment on the logic. Is it correct? If not, where did I go wrong? If a student has their locker in the math wing of the upper hallway, they are a freshman. Sonia has her locker in the upper math wing. Therefore, Sonia is a freshman. What do you think about that logic? So let's talk about that conditional statement. The hypothesis, the initial statement, assumes that the lockers in the math wing of the upper hallway. The conclusion is that everyone in there is a freshman. So if Sonia's locker is in that upper math wing, does it mean she's going to be a freshman? Absolutely. That logic is absolutely correct. So here we go. The fire alarm rings, then we're going outside. We went outside. The fire alarm rang. Again, our hypothesis talks about the fire alarm ringing. When the fire alarm rings, what are we going to do? We're going to go outside. Now, what happens if we just went outside? Does it mean that the fire alarm rang? I don't know about you, but come springtime, I know I'm going to want to plan some little trips outside during our class and go discover some math outside. What about you? Absolutely. This logic is absolutely incorrect. So where did we go wrong? Well, have you ever heard the expression, don't put the cart in front of the horse? I know my dad used to tell me that all the time. What we did is we started with our conclusion and we worked backwards. Can't do that. It doesn't work that way. The hypothesis stuff has to happen to allow the conclusion to be formed. Any questions about that? If you do, we'll definitely go over some more examples tomorrow. Alright, this is the end of our big meat and potato kind of lesson. What kind of questions you got? We're all on the same page? If you have questions, let's make sure we address those tomorrow. I think today's lesson should have been pretty good, but you never know. Anything you were a little bit unclear of, please make sure you go back and rewind, watch the video one more time, at least that section, and write down questions that you still have. On a side note, some reminders. First reminder, don't forget, tissue is due by Friday. No late tissue is going to be accepted. Secondly, if you're interested in information about mathletes, come and talk to me. Talk about extra credit associated with that as well. A good way for math students to earn extra credit in math is by doing more math. Last but not least, don't forget, home football game tomorrow. We all need to be there. Cheer on our Titans towards a victory. Have a good one.